Okay, today we're going to start one of the last parts of our foldable. It says conditional probability, and this is under the Unit 12 foldable on probability. So there'll be 3 total slides that we'll do, so leave a little bit of room because we might do a little bit more on this tomorrow. But today we're going to do 3 slides on conditional probability. Okay, in general, conditional probability is the probability of one event occurring given that something else happens or something else already occurs. So what you're going to find is they're going to tell you find the probability that a marble is red given that you aren't going to draw a green marble. Okay, so what it's doing, it's eliminating some of your options. Okay, so some of these will feel logical. Okay, some of them won't. This is the formula right here that's written if you want to find conditional probability. So the probability that you're going to find A given B is the probability of A and B both together divided by the probability of B. So we're going to talk about that in the next 2 slides. The first slide that we're going to do is going to be more logical. And the second one we're going to do is going to end up using this formula more to do the problems. All right, so you'll remember this chart that we've used several times in our foldable, so you don't have to write it again if you already have it written down. But go ahead and at least write the problems 1 through 5. And I'm going to go ahead and write for each one what it stands for. So number 1 is really saying the probability that somebody does soccer. I can spell soccer right. Probability somebody does soccer given they are male. Okay, that's really what it stands for. So here's what you know then. You're going to find the probability somebody does soccer given you already know they're a male. So if I already know that this person is a male, that means there's only 21 people in that group that I'm looking for that did soccer. So I already know they're a male, so that's the bottom number. Okay, so out of the 21 males then, how many did soccer? Well, that answer is 15. Okay, 15 did soccer out of the 21 that are males. And again, I would reduce that. I believe that reduces down to 5 over 7. Okay, I want to make sure my answer is in reduced form. Okay, number 2 up here, again, if I write it out, that's the probability that somebody is a male knowing or given that they play soccer. So I'll just write that they play soccer. Okay, so you already know that. So again, on this problem, it's already eliminating part of the group. You already know that the person does soccer. So the total number of soccer players is 20. So out of those 20, how many are male? How many are male? And the answer is 15. So you have a 15 out of 20 chance that somebody is male, given that you already know they play soccer. Okay, and that one would reduce down to 3/4. Let's skip down a little bit. Let's go to this 4th one down here since it's similar. So this one would be the probability that somebody is a woman, given they play basketball. So I'm going to write that up there. So I already know they play basketball, so that limits the group down. So if we look up here, the total number of basketball players is 30, so that's my bottom number. So out of those 30, how many were women? And the answer is 24. Okay, so 24 out of 30, which I believe reduces down to 4/5, is the answer for that one. Let's go to number 3 now. Number 3 and 5 are old questions. So number 3 is a pretty simple question. What's the probability somebody does basketball? So it's not given any information, so I'll just do it like a normal problem. So there's 50 total people that were surveyed, and out of the 50, we know 30 played basketball. So it should be 30 out of 50, or 3/5. Okay, so that one's an old question. Number 5 is also an old question. So what's the probability that somebody is a woman or a soccer player? So again, they didn't give you anything. They didn't eliminate any groups, so it's out of 50 people. Okay, so the number of women up there, okay, the number of total women we know were 29. Okay, the number of soccer players, the total number of soccer players was 20. So that's either women or soccer players. And remember, you need to subtract away where they overlap. So women and soccer players, there were 5 of them. I don't want to count that twice, so I'm going to subtract away 5. So that gives me 44 people out of the 50 that fall into that category. And when you reduce that, That's 22 out of 25, okay, for that probability. Okay, this is our last slide. Now we don't have a chart, but I do have the information. So on this one, we will have to use that formula because it may not be as logical. So again, I'm going to write it up here. So the probability of A happening given B happens, remember, is equal to the probability of A and B divided by the probability of B. Okay, because the probability of B is going to limit how many people are being interviewed or surveyed or whatnot. All right, so number one, this stands for the probability that it lightnings given that it's going to rain. So you already know it's going to rain, and it wants to know the probability that it will lightning, knowing it's going to rain. So I'm going to have a fraction, and it says up here in the formula, find the probability of both things happening. Okay, put that on top. So the probability that it lightnings and rains is 15%. Okay, that's given to you in the problem. Divided by the probability that it will just rain, because you know it's going to rain no matter what. So that probability is 55%. So 55%. So if you divide those on your calculator, okay, you end up getting 27% or 0.27. Okay, number two, kind of similar. Number two stands for what's the probability it's going to rain given that you know there's lightning, that there's going to have lightning. So if we look at that, remember we're going to put the probability that both of them happen, so 15%. Okay, ignore that period. Divided by the probability of the one that was given that it's going to lightning, which is 20. Okay, so again, if you divide that out, you end up getting 75% or 0.75. And that should make sense. Probability that it'll rain knowing it's already lightning. Usually it rains when it lightnings. And the probability of lightning knowing that it's going to rain, well, it doesn't always lightning when it's going to rain. So those should kind of make sense. Number 9 and 10 are old questions. Okay, number 9, see the word and. Okay, so I want to know when two things are going to happen, two events. So remember, you multiply each separate probability together. So the probability that it will not rain, well, if there's a 55% chance it will rain, that means there's a 45% chance that it won't rain, times the probability that it won't lightning. Well, if there's a 20% chance it will lightning, that means there's an 80% chance it will not. If you do that, I believe you get 0.36 or 36%. Okay, our last one is an or statement. So we know we're adding. So the probability will rain or lightning. Well, the probability it will rain is 55%. The probability that will lightning is 20%. And remember, to be careful, subtract where they overlap. Okay, so when it rains and lightnings, that's 15% because I don't want to count it twice. So when you do that, you end up getting 60% or 0.60.